Our project aims to develop a simple calculator using the Qt-Spin assembly language tool, a simulation environment for mixed programming. This calculator performs four basic arithmetic operations: addition, subtraction, multiplication, and division. User can input two integers, select an operation, and receive the result. The program includes essential features such as handling division by zero gracefully by displaying an error message. Additionally, we explore potential enhancement like continuous calculation with an advanced function such as modulus or exponentiation depending on time and complexity. This project reflects our goal of understanding assembly language programming while delivering a functional and intuitive user experience.
Let's dive into the implementation detail. Simple character program. This design utilizes MIPS as a language to perform this arithmetic operation efficiently. This program is structured with two key segments: the data section which stores user prompt, error message, result, and the text section where the logic for input operation and output implemented. We use specific register to streamline functionally instant. T0 and T1 store user input, while T2 manage arithmetic operation, and T3 hold the result while A0 point to display message, and B0 handle the system call for input and output. The process is started by reading numeric input and desired operation. The program then validates the operation and perform addition, subtraction, multiplication, or division, complete with a zero division check. Error like division by zero trigger a specific message. Final result of error detail are displayed using the system call function or seamless user interaction in summary. This means simple calculator combine the logic and process error and to deliver accurate arithmetic result.
This slide shows the output of the program that we create. As you can see, the program handles operations such as addition, subtraction, multiplication, and division. It also includes error handling, as demonstrated in the case of division by zero, where an error message is displayed to guide the user.
Purpose and how control structures contributes to the program functionality. First one is branching for arithmetic operations. The purpose is to determine which operation the user selected and directs the program to the corresponding section. It ensures the program carries out the correct arithmetic operation based on what the user selects. Second one is division by zero check. The purpose is to ensure that division operation only proceed when the second integer is non-zero, to prevent runtime error caused when the first integer dividing by zero. The third one is error handling for invalid operations. The purpose is to identify invalid input for the operation. It is to ensure the program handles unexpected input smoothly by showing an error message and ending properly. And the last one is result display. The purpose is to display output of the final compute result to the user. It is to make sure the user receives feedback from the program after the operation is complete. Understanding conditional checks and program flow control. The first one is branching based on the arithmetic operation. The back checks if the user's input match the ASCII codes for the operations. If match, it jumps to the corresponding operation, and if no match, it goes to invalid operation. It control flows by direct the program to the correct operation or error handler based on the user input. The second one is division by zero check. During division, this instruction ensures that the second operand is not zero. If integer 1 equals to 0, the program jumps to division error, displaying an error message and terminating. Otherwise, the program continues to perform the division. The third one is invalid operation handling. It handles cases where the operation entered by the user is invalid. By redirects the program to display an error message and exit cleanly, ensuring no undefined behavior occurs. Next is displaying the result. It displays the final result after valid operation is performed by ensures that program execution flows logically to result display after computation. And the final one is program termination. It ensures the program terminates gracefully by marks the end of the program and prevents further execution.
For control flow and error handling, that we define essential string for user prompts and error message. This include message to request integers, arithmetic operation, and a special alert for division by zero. The main control flow begins by prompting the user for two integers and operation. Based on the input, the program selects the corresponding arithmetic operation such as addition, subtraction, multiplication, or division. Division requires extra care. If the second integer is 0, the program redirects to an error message, ensuring no invalid operation crash the system. Control transition are managed through conditional branches, guiding the program to appropriate computation or error handling path.
In this section, we'll discuss the user interface design of our calculator program and how it ensures an easy experience. The program starts with clear prompt. First, enter first integer for the first number. Second, enter second integer for the second number. Then, enter operation to select the main operation. This instruction helps the user know exactly what to input. Once the user provides the input, the program calculates and shows the result, like result is 15. If there's an error, such as dividing by 0, the program shows a message, error division by 0. Invalid result also provide feedback. To improve the experience, we add first enhance error message. Easy to understand messages like division requires a non-zero second number. Second, format result. Clear output like 10 plus 5 is 15. Third, recalculation option. After its calculation, the program asks if the user wants to perform another operation without restarting. Fourth, feedback for successful operation. A message like calculation complete successfully after each correct result. Fifth, consistent visual structure. We use separator to keep the interface neat. This feature makes the interface user-friendly and ensures a smooth, error-free experience.
There are several challenges we face while developing our simple calculator program and how we overcame them. First, we tackle the issue of division by 0. Without proper handling, it could crash the program. So, we added a condition to check the denominator, and if it was 0, the program displayed an error message instead of crashing. Next, managing the control flow was tricky. The jumps and labels for each operation had to be precise, or the program would go off track. We fixed this by organizing the label clearly and testing every scenario until it works seamlessly. Input validation was another challenge. We needed to make sure users enter valid integers to avoid errors. Adding a quick validation step ensured only proper input were processed. Efficient memory management was also key. With limited resources in assembly, we carefully planned how to use registers and memory to keep things running smoothly. Finally, debugging tests our patience. By stepping through the code line by line, setting breakpoints, and adding comments, we managed to identify and fix issues effectively.
Program demonstrates the structure of a simple calculator while showcasing key programming concepts. It emphasizes branching, input-output handling, and robust error management, all critical in low-level programming. Each operation, like addition or subtraction, is isolated into label blocks, making the code easier to debug and maintain. Error checks, such as handling division by 0, enhance reliability. The clear separation between input processing and output further strengthens its design. Reflecting on the project, produced a great example of combining arithmetic functionality with error handling. It offers valuable lessons in modularity and edge case planning, essential for low-level systems.